welcome back. Today in the garage we're going to be discussing multi-battery applications. So vehicles that use more than one battery. We'll talk about why there would be a need to use more than one battery in a vehicle and how you could add a second battery to a vehicle and what you would possibly want to do that for. And some precautions that need to be taken if there's going to be multiple batteries in a vehicle. So first of all, we should probably understand what this battery is up against in a vehicle to begin with. So as we learned in a previous video, if it's an SLI battery, that's a starter, lighting, and ignition battery, this battery is going to be designed to produce some pretty high current surges, as well as smaller amounts of current for longer periods, like if you wanted to run the lights with the engine off. And the starter motor, its biggest consumer of power here, the biggest electrical load. So this is going to be bolted to your engine somewhere. This is going to be gear driven to the flywheel or the flex plate on the engine. There's going to be a big heavy cable that leaves the positive side of the battery. Usually it's the positive. We haven't mentioned this yet in a previous video, but generally speaking, the negative side of our battery is grounded. We use a negative ground system. There were some older vehicles and some off-road equipment that used to use a positive ground. So if you're working on something that's old, like from the 50s and maybe even early 60s, and also some mid-60s British cars, you have to be a little more careful about which side is grounded. But we can talk about that at another time. When you activate this starter, when you turn the key and activate the starter, there's going to be a considerable amount of current going to run this starter motor. And this is really the main reason for having the battery in the first place, so we don't have to hand crank start things. So as far as what's normal, nowadays 100 to 125 amps is pretty typical with our smaller engines, our more efficient engines, although on some of your older applications you could find up to 200 amps even flowing in your starter circuit. So 150 to 200 for older engines, older starter motors. So that's a pretty hefty demand. It's going to be a large cable to carry that much current, because the current you're trying to carry in a circuit is going to be what determines the gauge of the wire. Battery cables are usually pretty heavy, like 4 gauge or 2 gauge cables, and they need to be to carry this amount of current. Now, these are for kind of average engines. So 100 to 125 amps, so modern small 4 cylinders and little V6s, maybe up to around 150 for a bigger V8. Those would be your average engines. As you get into bigger and bigger engines, or engines with higher compression, diesel engines for example, then you're going to need more power to spin that engine over, and to get more power out of a starter motor, you're going to need more current, or you're going to need more voltage. So make this a nice easy example. Back in the day, your old direct drive Chevrolet starters were about 1.2 kilowatts, or 1200 watts of power. That's what they were rated at. And watts, or power, equal volts times amps. So 1.2 kilowatts makes it kind of easy to do the math. If it's a 12 volt battery, 1200 divided by 12 is going to equal 100 amps. 1200 watts, 12 volts, that's 100 amps. So if I alter the voltage, I can alter the amperage to get the same amount of work done. So if this was back in, say, the 1940s, when we had 6 volt electrical systems, if I cut this voltage in half to get the same amount of work done, I'm going to have to double my amperage. So that puts a greater strain on my wires, my cables. There's more current flowing. The battery has to be able to produce the higher current. So going in the other direction, for example, 24 volts, the current would be cut in half. So basic math, if volts times amps equals watts, if you cut one in half, you have to double the other to make up the same total. So that's one of the reasons, actually that's the biggest reason, that we find vehicles using multiple batteries. So I'm going to talk a minute here about how we connect these multiple batteries and what your results are. So for most smaller vehicles, when I say smaller, I mean pickup trucks, F-350s, F-250s, 2500 and 3500 Chevys and Dodges, light and medium duty pickup trucks, when we see multiple batteries, they're going to be in parallel. Because these vehicles are still going to run a 12 volt electrical system. So if we have parallel batteries, there's a 12 volt battery here. Usually on the other side of the engine compartment there'll be another 12 volt battery there. They're usually about the same size battery, if not the exact same size battery. The negatives of both batteries are going to connect to ground. So basically that's negative to negative connecting through the chassis. And the positives of both batteries are going to be connected to each other. And there'll be another wire leaving one of the batteries, going to the starter and the electrical system. Okay, so the rules in parallel circuits are that the voltage will be equal, but the current is going to add up. So in this system, we're still going to have 12 volts, but we're going to have the amperage of both batteries added together. So if this was a 600 cranking amp battery, and this was a 600 cranking amp battery, we're going to end up with 1200 cranking amps available. Okay, so the volts stay the same. And the amps add up. So that gives us up to 1200 amps available to play with, to run our starter, to run extra loads. Perfect for a pickup truck if you're going to be running an electric plow setup or a winch or something like that. The extra available amps are going to be there to run your accessories, and it's still a 12 volt system, so we don't need anything special as far as the charging system. It's still a regular 12 volt alternator. Everything in the vehicle still runs off of 12 volts, just like you had only one battery. When you have two batteries in parallel, a couple of precautions. If you disconnect one battery, like for example, I disconnect this, and you should always disconnect the ground side first. Let's put that back there. The reason you disconnect the ground first, by the way, we haven't discussed this yet either, is if I was to drop a wrench somehow between this battery terminal and the chassis, and it became grounded, it's not a short circuit. That terminal's already grounded, so that's not a problem. Whereas if the battery was grounded and I accidentally dropped a wrench from the positive terminal to something grounded, that is a short circuit. You're going to make big sparks. You're going to blow a spot off of your terminal. You're going to melt spots on your wrench. If there's hydrogen around the battery, because we know that hydrogen is released when you charge a battery, we could make an explosion. So for that reason, always disconnect your ground first. So let's say we disconnected our ground. Because this battery is grounded, when I go to disconnect this connection, that's still a hazard. I need to disconnect both grounds if I'm going to disconnect these batteries. So we disconnect both of those grounds first, then it's safe to disconnect the positives. And the same goes for reconnecting. We would want to connect the positives of both first, then individually connect the grounds of the two batteries second. Okay. These batteries need to be disconnected if you're going to test them. Because when they're in parallel, let's put our connections back. When these batteries are in parallel like this, if I was to hook up a battery tester to this battery, it's also connected to that battery through the wiring, through the cables. So it's not going to give me an accurate reading. I can't actually test the two batteries. You can charge both batteries with them wired up together. If that's something that you wanted to do, if you wanted to hook your battery charger up, if you hook it up to one, you're going to charge both at the same time. So that is an acceptable practice. It's also acceptable to disconnect them and charge them separately, but you must disconnect them in order to test them. Okay, so to sum up parallel batteries, parallel connections, okay, the volts are the same, the amps add up, we need to disconnect them to test them. All right, so those are the major precautions. Disconnect them both to test them. Disconnect your negative terminal first. And you can leave them connected to charge. All right, so same volts, more amps. And I should also add, they don't have to be the same size battery as far as amps go. As long as they're both 12-volt batteries, or they're both 6-volt batteries, or whatever the voltage is, that's fine. They can be different amperage batteries. So sometimes people, when they add electrical accessories, they might want to add a second battery for a little more amperage capability, and that's fine. They don't have to be identical batteries. It works a little better if they're identical, because they're going to discharge and recharge more evenly. So just something to keep in mind. So that's parallel. Now let's talk about series. So, series batteries. When you have a series connection, here's one battery, here's the other. 12-volt battery here, 12-volt battery here, 600 cranking amps, 600 cranking amps, negative, negative, positive, positive. The negative of one side is going to be grounded. The positive of this battery is going to connect with a jumper over to the negative side of that battery, and then the positive of this battery is going to go to your electrical system. And in series, the rules are a little bit different. In series, the voltages add, but the amps are going to stay the same. So, same amps, and the volts add. Ooh, excuse me. Guess I have to sanitize my marker when this video is over now. Alright, so same amps, voltages add. So this would be used in an application where we have a very high power starter that needs to be operated. So something like a big piece of construction equipment, or maybe a semi-truck or something like that. Big starter, going to be turning a really big engine. By using double the voltage of a 12-volt system, we can get away with half of the amperage. So that's why they do that. And a lot of applications, they'll have two batteries, but they're not in series all the time. There's a module that switches them into series for starting purposes, and then lets them go to parallel for regular charging purposes. In other applications, they'll just run a wire off of here to go power 12-volt items, and they run this one over to the starter for 24 volts. So they kind of use a dual voltage system. That's up to the manufacturer of the equipment, how they do that. So you can see it both ways. It can be done both ways. All right, so precautions here. First of all, these two batteries should be identical. You shouldn't put different batteries in series. And the reason is, let's say for instance, this is a 400 amp battery, and that's a 600 amp. I'll still get my 24 volts. The voltages will still add, but I'm going to get the amperage of the weaker battery. Basically, that's all I'm going to get. So, same amps, I should probably rewrite that. I'm going to get the amps of whichever battery is weakest. amps of the weakest battery. So you shouldn't be mixing different amperage rating batteries. They should be identical. So in this case, 600. Now, in theory, if these batteries were new at the same time and put into service at the same time, they both were properly maintained. They both had a hold down, so one wasn't suffering some vibration damage or mechanical stress that the other one wasn't. They should basically cycle together. They should charge and discharge together, and they should both basically reach the end of their life at about the same time. So it is possible for one to degrade a little worse than the other. If, again, some sort of mechanical stress got to that battery, if something happened and it broke a couple of the plates inside and you started to lose amperage from that battery, you have lost amperage everywhere. And if it loses voltage for whatever reason, like if it got a shorted cell and it dropped down to 10 volts, because you lost one cell's output, you wouldn't have 24 anymore. You'd have 22. So they need to be maintained together. They need to basically be replaced together. You shouldn't replace batteries in series applications individually. They should all be done at the same time. So, and another example of series batteries, by the way, that you might run into, maybe you've even used one before, is electric golf carts. A lot of electrical equipment that's meant to be charged up, like floor polishing machines, golf carts, pallet jacks, things like that. They run large lead acid batteries, and there's usually quite a few of them in series. The last golf cart I had to work on had 6 8-volt batteries in series. So the negative of one was grounded. The positive of the last one actually went to the switches and the controls of the golf cart. And the rest of them were all daisy chained in series. So at 8 volts a piece, 8 times 6, that was a 48 volt system. And that was an expensive bill when that customer needed batteries because they needed all of them. So I think those batteries were about $200 a piece. So you do the math on that one. Not cheap. Alright, so our series connections, you get the amps of whichever battery is weakest, you get the 2 voltages added together. They really should be the same battery as each other, and they should be serviced at the same time. They should be serviced together. As far as precautions go, if you disconnect any connection here, like if I disconnected the wire right there, you've broken the series. But this wire here, if it came in contact with that one, could still make a short circuit, so you'd still have to be very cautious. The best way to approach this would be disconnect your ground first, and then disconnect your final positive connection second, and then the ones in between you can disconnect after that. As far as testing these things, you can test each battery individually, even if they're still part of the chain. That's something that you can do. So if I hook up a tester, say, to this battery, I can do a test on just that battery. So that's perfectly fine, unlike parallel. But again, just a precaution that needs to be taken. When you charge these, unless you have a dedicated 48 volt charger in this case, or if it was a 2 battery system like for a truck or a piece of heavy equipment, a 24 volt charger, you can charge the 2 of them at the same time. What's more common is to disconnect them all and to charge them individually. Okay, so we talked about charging, we talked about safety as far as making and breaking our connections. We talked about isolating the batteries in parallel to test them and to make sure the circuit is broken to the vehicle. And we talked about how we get our amps and how we get our volts and why you would want more volts in a system. So that about sums it up. If you're going to add a battery to a 12 volt vehicle, obviously you're going to need to do that in parallel to keep with the same voltage that the system was designed to operate on. And if you're going to be running something special, race car or drag car that needs a high voltage starter or something like that, then you're going to have to either switch to a dedicated 24 volt electrical system, or you're going to have to put one of those special switches in that puts the batteries in series for starting and in parallel for normal operation. So that about sums it up. A little bit shorter of a video for us. Hope you enjoyed it, and you can always put some questions in the comments and I will answer them. So that's it for now. Take care, folks.